what we're trying to achieve is proving that with today's current technology, it's feasible to take people to Mars, proving that we have the solutions already. We can take existing solutions like existing rocket solutions, existing re-entry solutions, put it together to create a systems approach to take people to Mars.
This is actually a really ambitious project. As we've learned from previous Mars missions, such as NASA's Curiosity and Phoenix landers, it is incredibly difficult to get any sort of payload across such vast distances and land on the surface, let alone a vessel full of astronauts. Not only do we have to get them down, but we also have to get them back. To do this, a huge number of engineering problems have to be overcome, covering a wide range of disciplines. Our Mars project team consists of 4 individuals, each focusing on a different aspect of the mission. We have a CAD and visualization expert, an orbital mechanics engineer, a chief safety officer, and a technical manager.
I'm the orbital mechanical engineer. I'm in charge of the trajectories and the mission phases towards Mars from Earth and back again. There's a lot of complex situations sort of throughout the whole project. There's got the launch phase, the transition between low Earth orbit and getting to Mars itself, maneuvers that could redirect the course of the actual rockets itself. There's a lot of payloads that need to get there before the actual crew itself. There's landing, there's all these possibilities of failures that could happen, and we have to get them back, which is probably the main thing that could go wrong.
I'm a proud member of the Mars manned mission team and have been since March of this year. I've taken up the role of Chief Safety Engineer, and in that role I have to cover everything from the risks associated with the group dynamic to the risks that are actually associated with the mission itself. There's a lot of risks that could affect the success or failure of this group. They are loss of contact, loss of data, time management, scheduling, and group disagreements.
So one of the major components of my role in the team is to ensure that our time is managed correctly and that our goals are met in a timely manner. And to do this, the best way that we have found is to use a Gantt chart. So we have a running Gantt chart for the team that contains a number of different milestones, which is continually updated as we complete tasks.
I'm responsible for creating computer models and simulations of everything from landers to launches to habitats on Mars. So my role is to come up with designs, structural analysis, and computational fluid analyses to model the types of environments where these crafts will be encountered in.
The failure modes and effect analysis identified 2 main risks that are going to challenge the mission. The first is the risk of developing sickness from cosmic radiation. The second risk that challenges the mission is re-entry into Earth's atmosphere, due to its extremely high consequences, high severity, and low detectability.
So one of the existing solutions for a Mars manned mission is Mars Direct. This proposal was designed by NASA engineers, and in this proposal they came up with a novel solution to creating artificial gravity. The idea is to use a tether in transit, which will deliver 38% of the force that Earth's gravity provides.
Our team is loosely based on a network hierarchy. So we have leaders and experts in various fields, but in an overall sense we help each other out. We take on different roles, but there are some people who have more of an influence in some areas.
As a team, we mould well. Everyone has their own little different requirements that they need to do and their jobs, so it's easy to get along with them, and everyone sort of helps each other out a lot. Everyone knows what they need to do, and for the mission to be a success, we need to be very focused.
This is a mission, a logistical nightmare, but we will succeed.